Hello. Today we are going to explain about buddy system. So, basically, buddy system is a memory allocation and management technique that is used to allocate memory dynamically from fixed size partition. So, how does it work? Here's how the buddy system works. First, the system's memory is partitioned into blocks of fixed size that are powers of 2. Example, 1 kilobyte, 2 kilobyte, 4 kilobyte, and etc. Each block of the memory is packed with another block of the same size and they are called buddy blocks. Now, when a request for a block memory comes in, the system looks for a free block of memory that is closer size or larger to the requested size. If the found block is larger than needed, it is split into 2 buddy blocks of half its size. Then, when it is no longer needed or released, the system checks if each buddy block, if available, is also free. If both buddy blocks are free, they are merged back into a larger block of memory.
Now, we will explain it using a real-life analogy. Imagine we are managing parking space. We will have different parking spaces, large for buses, medium for cars, and small spaces for motorcycles. Each space is dealt with the size of the small one. So, if a car comes in and we only have a large, we can split the large into 2 medium space. And if a motorcycle comes in, however we only have medium space, it can be split into 2 small spaces. Now, you might wondering why if a bus comes, where we give the large space to it directly.
Now, to understand the concept of buddy system better, we will answer a question from past year exam. Consider computer system that has 1024 memory megabyte available. Process size is as defined with A is 150 megabyte, B is 228 megabyte, C is 365 megabyte, and the memory request with the sequence of request process A and B, releasing A, requesting C and D, and lastly releasing C. When the information is given, show the result of each memory request or release using buddy system and also to calculate the total of internal fragmentation in M unit after C has been released. When the 1024 mega block is divided into 2, we will get 512 megabyte, which is too big for process A. So, we will divide it into 2 again, resulting to 256 megabyte, that is again too large for process A. Next, we divide it into 2 again, that will get us 128 megabyte, which is the best fit for process A. Process B will straight away enter into 256 megabyte block since it is the best fit. When A is released, we see that 128 megabyte has now merged to 256 megabyte. Since request C is 356 megabyte, which is bigger than 256, we will use the 512 megabyte block. For request D, we will divide our block until we found our best fit, which is 64 megabyte. Then, when process C is released, the 512 megabyte block is empty.
We will now compute the internal fragmentation for each process that is running in the memory block in order to determine the overall internal fragmentation of the process C has been released. After deducting the 228 megabyte process B memory requirements from the 256 megabyte block, internal fragmentation where B resides equal to 28 megabyte. The 64 megabyte block will then subtract the 54 megabyte. Process D memory request, leaving 10 megabyte. Thus, the total of internal fragmentation after process C has been released is 38 megabyte. That's all from us. Thank you.